So in this video we'll discuss some of the basics of GeoGebra. Now at the top here we have several icons that are going to be very helpful, and each of them have drop-down menus. Within those you can find several items that could be used to help you build constructions. Of these icons, the most important one to always remember is the arrow, which means to move, because that arrow needs to be clicked when you want to shift and move things around in the image. So if you want to click and drag, you have to have the arrow selected. We have points, issues with lines and segments, constructions of different types of intersections, ability to create polygons, circles, conics, measurements of angles and length and area, even slope, transformations, create some different things like inserting images and text, sliders, and then this ability to zoom in, zoom out, and to even move objects. So if I don't like, for example, the move, I don't like the fact they keep the axis to the left. Maybe I want to move it using that move tool so that it's more centered, and that's something I can do. Now I need to use the move for that. So we're going to go through here and actually talk about, well, how do we construct a quadratic function? So if I think about it, a general one, I could type in, I've got this input bar in the bottom, and whatever I input, it'll create that function. So if I did y equals x squared or f of x equals x squared, I can see a little bit of the difference between them. But so since we're going to call it a function, let's do f of x equals x squared. And you can see here is our function. Now if we wanted to talk about transformations, we'd have to type in individually one by one and see them, but we can do much more than that with a dynamic program like GeoGebra. The first thing we need are sliders. So if we look here, this icon is to create sliders. So I'm going to click on it. I'm going to name my sliders based on thinking about vertex form of a quadratic function. F of x equals a quantity x minus h squared plus k. So I need the a. I can make my minimum go from -10 to 10. I can change this at any time. I'm just going to use those for now. And I'll keep the increments of 1/10. It's good to have increments that are decimal values. You could even make it finer grain if you want, but it helps see that transition a lot better than if you used integers. I want a second one, so I'm going to do the same thing again, right below. This time I want the h, since that's common terminology we use, and I want k. And I'll make that -10 to 10 as well. Now, as you notice, they're not very well lined up. So what I can do is if I go back to my move tool, the arrow, and I right click, I get options, and it says fix object. If I take that fix object off, I can now shift my slider. And if I like where it is, then I can either leave it off or I can fix it back. Again, that's right click on a slider, remove that fix object because that's now on top of it, it's too far over. Put it under, and I'm happy with it there, so I'm going to go back and fix it. So I see my sliders now shift. It's not doing anything, but at least the numbers are changing, so nothing's changing in my image now. But let's think about the way that we write the function for quadratic. So we've already done f of x, so we need to do a new function, so we're going to call it anything you want. I'll do mine as g of x, and that's going to be equals, well, I have the a and x minus h quantity squared, so I use the caret key to do that squared, plus k. Now if you look at my equation down here, you can see that different things change colors based on what they are. So that's kind of a nice feature. You can tell that your sliders are actually being used. And when I do that, I'm going to click and drag this so I can see the full function. It keeps that vertex form, and I can see as I drag A, it changes the shape. I drag H, I'm getting my horizontal shift. I drag K, I get my vertical shift. Now maybe I want to have also the general form, and this is a unique function of GeoGebra, that here I used the function notation. Say instead of using function notation, I used y equals. it creates the exact same function, except now it puts it in general form and it recognizes it as a conic instead of as a function. And it has different aspects that can be utilized within that. So it is important to recognize that calling it y equals versus g of x equals does change some of the features of what I can do in GeoGebra. However, what's really neat about that, I can now compare what does the vertex form look like compared to the conic, which could be quite useful depending on what I'm trying to do in my class.